Okay, so we're going to continue on with the example we were working on in the previous video. Okay, so in part B of this question, it asked us to read the label in the figure and that the manufacturer directions state that weight-based dosages are calculated on the TMP component of the drug. So remember, this is a drug with two components. And it says, how many milliliters will you withdraw? Okay, so this is the amount given in the order, 75 milligrams. Okay, and according to the label, okay, the second component of the drug, which is this one, it has 16 milligrams per milliliter. Okay, so that's what we're going to use. So 16 milligrams per 1 milliliter. So if you flip that over and multiply by the 75 milligrams given in the order, right, we would administer approximately 4.6 milliliters. Okay, now keep in mind that normally, right, you would round that up to 4.7. Okay, but the book does specify that for pediatric dosages, right, to avoid an overdose, what the book does is they round their answers down. Okay, so in other words, 4.68 rounded down it goes to 4.6, so that 6 stays as a 6 rather than going up to a 7. Okay, so the answer to part B is approximately 4.6 milliliters. Okay, and then on part C, it says, using a volume-controlled chamber, how many milliliters of IV solution will you add? Okay, so this is the part that's actually a little bit tricky because it's not quite clear, you know, whether you're taking the 100 milliliters of the D5W and then adding it to the 4.6 milliliters to administer the drug. So in other words, the order is given to the patient as an IV piggyback. Okay, so it would seem that you would take the 100 milliliters and then add it to the 4.6 milliliters to get a total of 104.6. So that seems like a reasonable answer. Okay, but if you look at how they work it out in the book, you can see that it says you would add 4.6 milliliters of the drug to the volume-controlled chamber. Okay, then add D5W to the 100 milliliter mark. Okay, so you're not quite adding 100 milliliters of the D5W. So in other words, since you're already adding 4.6 milliliters of the drug to the volume-controlled chamber, right, then you do 100 minus 4.6. So 100 minus 4.6, okay, to get 95.4. So after you've added the 4.6 milliliters of the drug, okay, so after adding the 4.6 milliliters of the drug, okay, add D5W, okay, until the solution reaches the 100 milliliter mark. Okay, so a volume-controlled chamber is calibrated. Okay, it's got calibrations on it, so you would add the 4.6 milliliters and then fill it to 100 milliliters. So you have a total of 100 milliliters. Okay, so in other words, 100 minus 4.6 will give you 95.4. Okay, so once you add the 4.6 milliliters of the drug, so you will add 95.6 milliliters of D5W for a total of 100 milliliters of solution. Okay, and that completes this example. Okay, so we got one more topic and one more example to do. Okay, it's called calculating daily fluid maintenance. Okay, Then it says here that the administration of pediatric IV medication requires careful and exact calculations and procedures. Infants and severely ill children are not able to tolerate extreme levels of hydration and are quite susceptible to dehydration and fluid overload. Therefore, you must closely monitor the amount of fluid a child receives. Okay, so here's the important part. So the fluid a child receives over a 24-hour period is referred to as daily fluid maintenance needs. Okay, and then you can read the rest of it on your own. But basically, this table tells you how you're going to calculate the daily fluid maintenance for a child whose weight is given in kilograms. So the table here, table 12.1, says that for the first 10 kilograms of body weight, okay, it's 100 milliliters per kilogram. Okay, likewise, for the next 10 kilograms of body weight, it's 50 milliliters per kilogram. And then for each kilogram above 20 kilograms is 20 milliliters per kilogram. Okay, so in the next example, we're going to determine the normal 24-hour fluid requirement for a child who weighs 33 pounds. Okay, so it should be obvious that our first step is to convert the child's weight into kilograms, from pounds to kilograms. So 33 pounds. Okay, multiplied by 1 kilogram over 2.2 pounds. Okay, so we're going to take 33 and divide it by 2.2. Okay, we get precisely 15 kilograms. So the weight of the child is 15 kilograms. Okay, so we're going to calculate the daily fluid maintenance for a child who weighs 15 kilograms. Okay, so it says for the first 10 kilograms of body weight, okay, the child's going to receive 100 milliliters per kilogram. Okay, so eventually we're going to get a total number of milliliters. Okay, that's what we want to know, right? How many milliliters in total of fluid, right, should the patient receive? Okay, so we're going to take the 100 milliliters per kilogram for the first 10 kilograms of the body weight here. So, in other words, it's going to be 10 kilograms. Okay, even though the patient weighs 15 kilograms, right? It's the first 10 kilograms that gets multiplied by 100 milliliters. Okay, so multiply that by 100 milliliters per kilogram. Okay, so 10 multiplied by 100. Okay, is equal to 1,000. So far we have 1,000 milliliters of fluid. Okay, and then according to the table next, okay, so for the next 10 kilograms of body weight, it's 50 milliliters per kilogram. Okay, but remember that the child only weighs 15 kilograms. So we've already accounted for the first 10 kilograms of the child's body weight. Okay, and the child weighs 15 kilograms. Okay, that means there's 5 more kilograms. So not the full 10, but there's 5 more kilograms. And then we won't use the last line of the table here. Okay, but basically, so for the next 5 kilograms, we're going to multiply it by 50 milliliters per kilogram. Okay, so 5 kilograms multiplied by 50 milliliters Okay, per kilogram. All right, so 5 times 50 is, okay, 250 milliliters. Okay, we're going to stop there because we've accounted for the daily fluid maintenance for the patient's weight of 15 kilograms. Okay, so we add the total fluid, right? So 1,000 plus 250, all right, is equal to 1,250. Okay, should be getting 1,250. So the daily fluid maintenance, okay, for a child who weighs 33 pounds is 1,250 milliliters. Okay, so that'd be the final answer, right? So the child would receive 1,250 milliliters of the appropriate fluid over a 24-hour period. So if the question had also asked for the pump setting in milliliters per hour, okay, you would then take the total amount of fluid, in this case for just 1,250 milliliters, and then divide by 24 hours in 1 day. Okay, so the pump setting would be approximately 52 milliliters per hour, but the question doesn't ask it. But just in case it does, right, that's how you would figure that out. Okay, so I encourage you to view the next example, okay, which is a little more involved than the one we just did. Okay, so example 12.13 says if the order is for half maintenance for a child who weighs 35 kilograms, at what rate should the pump be set in milliliters per hour? So I encourage you to work that out on your own. All right, and then view the solution to check your answer.